Chapter 1, Section 5, Segment and Angle Bisectors. The first thing we need to talk about is what is a midpoint. A midpoint is a point that divides or bisects a segment into two congruent segments. Notice a bisect means to cut into two congruent segments. What is a segment bisector? A segment bisector is a segment, ray, line, or plane that intersects a segment at its midpoint. Here I have an example of a segment. I'm going to have this red dotted line going through the segment at its midpoint. These blue little lines or tick marks show that the two segments created by the red line are congruent. So this red line could be called a segment bisector. It is a segment bisector because it bisects a segment at its midpoint, creating two congruent segments. The midpoint formula says that if A at x sub 1, y sub 1, and B at x sub 2, y sub 2 are points in a coordinate plane, then the midpoint of AB is, notice it's going to be another point, it's x sub 1 plus x sub 2 divided by 2 for the x value, and for the y value I add together y sub 1 plus y sub 2 and divide that by 2. Midpoint example 1 says find the midpoint of segment DE with endpoints at D 3, 5 and E negative 4, 0. Using the midpoint formula, I'm going to add together my x values and divide by 2 to find the x value of the midpoint. Well, 3 plus negative 4 is negative 1, and then divided by 2 is a negative 1/2. When I add together my y values, it's 5 plus 0 divided by 2. Well, 5 plus 0 is 5, and then divided by 2. I could write it as 5/2. I'm okay if you leave it like that. You could also write 2.5 or 2.5. Midpoint example 2 says the midpoint of segment XY is M at 3, negative 4. So they've given us the midpoint in this case. One endpoint is y at negative 3, negative 1. Find the coordinates of the other endpoint. This one's a little bit different from example number 1 because I'm given the midpoint and one endpoint, and so I'm going to have to use the midpoint formula to find the other endpoint. I can do this by setting up the midpoint formula and setting it equal to my known midpoint. Notice I have negative 3, which is the x value of the given endpoint, plus x divided by 2, and then comma, I have a negative 1, the given y value of an endpoint, plus y divided by 2, and I've set it equal to 3, negative 4, the known midpoint. I can take the x values and I can set them equal to each other, which would be negative 3 plus x divided by 2 equals 3. Remember, I'm going to have to multiply by 2 on both sides, and then I'm going to need to add 3 to both sides to get x by itself. So to solve for the x value, I would have 9. I do the same thing to solve for my y value. I need to multiply by 2 first, and then I'm going to need to add 1. And when I do that, I get negative 7. So the coordinate of the other endpoint is 9, negative 7. What is an angle bisector? An angle bisector is a ray that divides an angle into two adjacent angles that are congruent. So a bisector is something that bisects either an angle or a segment, and it's going to create two equal either angle or segments. Here I have an angle. This red dotted ray is an angle bisector because if you notice the arches, when I have congruent arches, they're going to have the same number of arches represented. So if you notice, each one of these created angles has one blue arch, which means that they are congruent. Angle bisector example 1 says that ray JK bisects angle HJL given that the measure of angle HJL it equals 42 degrees. What are the measures of angle HJK and angle KJL? Remember, you're going to hear me say it a million times this year. Go ahead and draw yourself a picture. I have angle HJK. Remember, J has to be the vertex because point J is in the middle of your notation. And then I'm going to have ray JK bisecting the two angles. So I'm going to go ahead and mark that they're congruent by putting my single arch in each angle. You are given that the whole angle HJL equals 42 degrees. We know that a bisector is going to create two equal angles. So what I can do is I can take the whole angle, 42, and divide it into two equal parts. So 42 divided by 2 equals 21. So each angle, HJK and angle KJL, are each going to be 21 degrees. Angle bisector example 2 says a cellular phone tower bisects the angle formed by two wires that support it. Find the measure of the angle formed by the two wires. Draw yourself a picture. Here I have this pinky triangle representing the tower, and I have the two wires that are supporting it. Notice I've already noticed that in the picture they tell me that one of the angles created by the wire and the tower is 47 degrees. It tells us that the cellular phone tower is bisecting the angle, which means that it's creating two equal angles. So if one angle is 47 degrees, then the other angle is going to be 47 degrees. It asks us to find the measure of the angle formed by the two wires, so the two black lines. To do that, we would need to add 47 plus 47. You could also do 47 times 2. It's the exact same thing. And when we do that, we find that the two wires create an angle that measures 94 degrees. Angle bisector example number 3 says that ray MO bisects angle LMN. The measures of the two congruent angles are 3x minus 20 degrees and x plus 10 degrees. Solve for x and find the measure of all three angles. Go ahead and draw yourself a picture. I have angle LMN, and then I need MO to bisect the angle. I'm going to go ahead and mark what we know. It says the measures of the two congruent angles are 3x minus 20 and x plus 10. It doesn't really matter which angle is 3x plus 20 and which angle is x plus 10, because remember, if MO is bisecting my angle, we have two congruent angles here. So go ahead and mark them. Now, if we have two congruent angles, we know that the angles should be equal to each other. So if one angle is 3x minus 20, we can set it equal to the other angle, which is x plus 10. Go ahead and solve for x. To do that, we're going to add 20 to both sides and subtract x from both sides to get 2x equals 30, and we find that x equals 15. They ask us to solve for x, but they also ask us to find the measure of all three angles. So we need to plug x back in for both 3x minus 20 and x plus 10. This will kind of be a good way to check our answer because we know that they should be congruent, so they should equal the same thing. So when you plug in 15 to 3x minus 20, you get 25. And when you plug in 15 to x plus 10, you also get 25. Now, the third angle that we need to find the measure of would be angle LMN, the whole angle. We could do 25 plus 25 or 2 times 25, and we find that the whole angle LMN equals 50 degrees. Today's assignment is on page 38. It's numbers 14 through 42 even, number 44 through 49 all, and numbers 62 through 72 even.